All right, so now we're looking at 9-53. It says, look at the data that you collected for the acute, obtuse, and right triangles. So here's our data table. What patterns do you see between the sum of the areas of the two smaller squares and the area of the larger square that form the triangles in each row? Copy and complete the sentence starters below in your learning log to summarize the patterns that you see. We're going to title this entry Triangle Side Length Patterns and include some examples along with the date. All right, so here the first one says, if three squares have sides that make an acute triangle, so we're looking over here at our data table that had acute as a result, then the sum of the areas of the two small squares, what? So we're going to be looking here at the sum of the areas of the two small squares, meaning the smallest area plus the medium area added together. So that's going to be this column here. How does it compare to the largest area or the largest square that you used? So how does it compare to the largest area? So you're going to use your table over there. And again, this is for acute triangles. And you're going to put your findings down below. And then you're going to look at the obtuse triangle section. So where you had obtuse as the triangle created by your squares, that's the section you're going to look at. So let's say this is my row. I'm going to look here. And again, I'm going to look at the smallest area plus the medium area. And how does it compare to the largest area? Is it equal to? Is it greater than? Was it less than? Whatever the case may be, you're going to write how it compares to the largest area, the sum of the area of the two small squares. And then finally, for a right triangle, which may be the most important, we'll be talking about it for the next few days. How does the small area plus the medium area compare to the largest area? Is it equal, greater than, or less than? All right, then you're going to move down here to problem 54. And this is all about using the patterns that you found, again, in this table up here, to predict whether each set of lengths below will form a triangle. If a set will form a triangle, we're going to state whether the triangle will be acute, obtuse, or right. So using the table, using your learning log, and this is going to help you come up with an answer and justify your conclusion. So we've got 5 centimeters, 6 centimeters, and 7 centimeters as our side lengths. But again, we want to deal with the total area of a square that we'd be using. So if I've got 5 centimeters and I wanted this as the area or the square version of it, I would need to extend it by 5 centimeters down. And this gives me a square of 25 centimeters. And it's the same thing as 5 squared. So 25 centimeters plus the area of the second smallest side length, which would be 6 centimeters. And again, if we square this, it's going to give us 36 centimeters squared. So 6 squared is going to give us 36 centimeters squared. And then we're going to see how that compares. So we can't write equals, we can't write greater than or less than, to the largest side length, which is going to have the biggest area, of course. Here's that square for us. And that would be 49 centimeters squared. So let's see, how does it compare to our 7 squared, otherwise known as 49 centimeters squared? Well, let's see. 25 plus 36, that gives us 61. And comparing that to 49 centimeters squared, it's going to be greater than. So going up to our learning log and going up to our data table, when the sum of our two smaller areas, our two smaller sides, is 61 centimeters squared, and it's greater than the area of our largest side, then what is the case? Is it acute? Is it a right triangle? Or is it obtuse? All right, so that's how you would answer that first question there, and then you can go on for the next 5 of these. And you don't have to show crazy work like I did. I just included some visuals. You could just be like, all right, 5 squared plus 6 squared, that equals 25 plus 36. How does that compare to my largest side squared? All right, so you can get rid of the drawings but they just personally help me out. And then you get on to the final question here, 9-55. And this is an additional challenge. We're going to again be using our findings from up above and our learning logs. So here it says Lewis wants to build an obtuse triangle. He has already decided he's going to use a square with an area of 81 square units and a square with an area of 25 square units. So then it asks, what area of square could he use to form the third side of his triangle? Explain your reasoning. Well, remember, these are square units that are given. So we can't think of it as a side length of 81 and a side length of 25. We have to be thinking about it as a square of 81 and a square of 25. And then, all right, what kind of square do we need here to finish it off? Now, you could also think about it in terms of maybe 81 is going to be that square that's slanted. It's going to be that final third largest side. So if the 81 were to go here, then what possible side length could go there? Okay, so there's a few ways that we can think about this. You may have different answers because there is a range here, but that's just kind of nice because it gives us a larger room to get the answer correct, right? You could put an exact number, or if you're like, oh, it could be between this number or that number, you can go ahead and do that. But we're going to have to start off by looking at what the rule is for obtuse triangles. How does the smallest plus medium area compare to the largest area? All right. And then when you figure that out, you're like, okay, so these sides have to be greater than, less than, or equal to the largest side, whatever that may be. And that's going to help you figure out the first question. And then you're going to do the same thing for the next one, except then it's asking about acute triangles. So you have to look at your learning log and see what that rule was. And again, please explain your reasoning for both of these and let me know if you have any questions at all. All right. Hopefully you guys had some fun with this activity. Hopefully it makes sense, comparing those square areas to the largest area and seeing what type of triangle it makes. All right. We're going to do some more with this the next few days, especially right triangles. All right. Have a great day.